Hello guys, welcome to Hola Tech. Today we are going to solve the lead code problem number 104, that is find the maximum depth of a binary tree. Okay, they will be giving a binary tree in this pattern, and we need to find how many heights it maximum height it can contain, right? So how do we find it? As you all know, the different types of traversal, that is level traversal or maybe in order traversal, pre-order traversal, right? So as it says by depth, right, then we can definitely go for a level adder traversal to find the maximum levels it can consist. There is another approach to this problem to solve. What is that? Is using a recursive. Most of the people prefer going for the recursive way to solve this problem. Okay, and how are we going to solve this? Let me explain you with the recursive. Later on I will talk to about using a level adder traversal. Okay, so when it comes to recursive way to solve this problem, basically it is a very simple maximum 3 to 4 lines of code to write and solve this problem. Okay, what we do basically we start from the root node. Okay, and we go towards the left or right. Okay, and when we are towards the left or right, say for example I started with the left node, right, and I find is there a value existing towards the left. Yes, if there is exist, again I go towards the left, is there a value exist, right? And if you see here, there is no value from the root from the ninth node, right? There's no value towards the left and right. When there is no value, what it going to return? I basically should return 0. Okay, this is going to return both the nodes towards the left and right of ninth going to return 0 0. Okay, now when we want to return from ninth towards the root node, right, basically we should return the current node count plus maximum of left and right. As I'm saying, left and right maximum, right? So please keep a note of this maximum of left and right. So what is the left and right here? 0 and 0. So what is the maximum? 0, right? So it's going to return 1 towards the root node, that is 1 is written in the left. Okay, when we move towards the right, okay, as you can see there is a node 20, correct? And when we are at the node 20, again we need to go towards the left, see whether there is a node exists. Yes, there is a node. So is there a left and right of the 15th? No, right? So what it going to return? Basically it's going to return 0, right? So we need to return those value towards the 20th node. So it's going to be 1 plus maximum of what is that? 0. So now it's going to return 1. Okay, so 15 returns 1. And now when we go towards the right of 20, we see there is a 7 exist, and again for the 7 we go left and right and we see there is no value exist, right? So basically it returns 0, correct? So this returns 0, this also returns 0. So now 1 plus maximum of left and right, it is 0. So what is going to return? 1, right? And what this 20 should return? Basically maximum of left and right. What is the maximum of left and right at the 20? So this also return 1, right? So 1 plus maximum of left and right is 1 comma 1, that is 1. So it's going to return 2. So as we see, for the root node we got the left as 1 and right as 2. So what we should return at the root node? So again we should do left plus root value, current node value, that is 1, plus maximum of left and right, that is maximum 2 comma 1 is how much? It is 2. So what is the final result here? 3. So this is the approach, guys. We need to take it in a recursive way to solve this problem. Okay, now I will write a program for this so that you can easily grasp it whatever I said so far. Okay, now var I say instead of that I can say like if root equal to very basic condition, it is base case, I can say it is equal to null, I should return 0. If not, I need to take a two vars, that is left count is equal to max depth of root of left, okay, and right counter we need to take it, that is max of root dot right, okay. And again when we return final result at each node, what we should do, we need to consider the current node, okay, consider the current node and find the max of left and right, that is left count. What is the left count return? When we are at the leaf node, it's going to return basically 0 0, right, comma right node, right count. Okay, now run the submit the code and say it works. Cool, and now it works fine. As you can see, we did this and it works perfectly fine. Let's find it out what is the complexities, right, time and space complexities for this approach. As you all see, we are going through from the root towards the leaf nodes, right, and we are not leaving any nodes behind, and also we are every time we are adding at each node one value, right. And by looking at this itself, you guys can guess it, like we are going through all the nodes, that means like it is O of n time, the time complexity, and the space, as you can see, we are not taking specifically an auxiliary, I can say auxiliary space complexity of O of 1, but it's not an O of 1, but at each node it's O of 1, but when you count all nodes it's going to be O of n. So I can conclude this as taking a time complexity of O of n and space complexity of O of n. Cool. Now we are going to solve this problem with the level order traversal. Okay, so before that I wanted to clear everything so that I can start the level order traversal. Okay, and I'm also going to delete this code. Okay, so let me explain you guys what is the level order traversal, right. So as you all know, might be already learned about level order traversal. We use a queue to store at a node at each level, and again we iterate through the queue for print the values, right. That's how we used to do. Similarly in this problem also we are going to use a queue, and along with that we are going to also store the value, that is the depth of each node. Okay, and when we are at the root node, we are going to store this root node, and we store the value depth as 1, and we move towards the left, and we again increase the depth by 1, and again we go towards the left of 9th, and if we see is there a left and right, if no, we return back, and again we go to the right, again increase the depth count by 1, again if there are left and right exist for a 20, right, if there is a exist we return it that value, right, similar to the recursive way, but we are storing in the queue data structure. All right, so let me write the program for this so that it can easily be graphed. So I'm going to write a base condition here, if root is equal to null, so I should return 0. Okay, and I'm going to take a queue here to store all the nodes in the link from the tree. Okay, and I'm not going to store only the node, I'm going to store even the depth, as I said, right. So in order to store both the values, I'm going to use a pair, that is node and int. Okay, and also I'm going to take a explicit variable, that is depth, to maintain the depth of a binary tree. Very first time when I'm at this root, I should add it to the queue. I'm going to add a root to the queue, right? That is a pair, that is root dot depth. Okay, that is 1, I can say it. While now I need to iterate through the queue in order to calculate the depth of a binary tree. So how do we do it? Until it is empty, is not empty, we keep polling the queue elements, right? So there is a pair, I can say. Once we poll it, we not going to get a node directly, right? We are going to get a pair. So that is pair queue dot poll. We get this, right? Once we got this, we need to check pair. Once we got this first, right, that is not null. What we should do, if it is not null, basically we should increase that, we should add that node to the queue, that is queue dot add, what is this, it left depth plus 1, because we need to current node plus the previous node plus the current node count. Okay, so again we should take the depth also here, it dot second, I can say it. Okay, now when we are done with the left, we should also add a right node also to the queue. Okay, it dot right depth plus 1. So once we add and keep looping throughout all the nodes, and it keep increasing the depth count. Once we are done with this loop, we should return the depth. Okay, now let's run this code and see it works. I think there is a mistake I did, I feel. Okay, linked list pair of, okay, this is not a node, basically this is a tree node, whereas they said all right. Are there any other mistakes I did? It dot left, so left, it's correct, left second, right? What is the key they given it? Okay, depth plus 1. What is the key I taken? Depth plus 1. Okay, now submit it again. So I think there is another mistake. Oh, it should not be and second here, right? It should be the pair dot second. It is the node, the first value in the pair is the node, right? Okay, there is another mistake here, we did it, that is it dot left node is expected, right? So this is basically a pair, we should add it, it's not a direct value, right? So pair of this thing, okay, pair of node and value. Cool, that's it guys. This is a very simple easy problem in the lead code regarding a binary tree. So yeah, thank you so much for watching. Please don't forget to like and subscribe. Stay tuned for the next videos. Thank you, bye bye.